Hello students, in previous e-lecture we have discussed about Bayes' theorem to solve the questions of reverse probability. In this e-lecture we will discuss questions based on Bayes' theorem. Students, read the statement of this question carefully. In this question, a student has to answer a multiple choice test. There are two options. Either student knows the answer or he guesses the answer. Probability that student knows the answer is 3 by 4 and he guesses the answer is 1 by 4. Also, probability that student's answer is correct given that he just guesses the answer is 1 by 4. Here, we need to find the probability that student knows the answer. It is given that answer is correct. Let E1 be the event that student knows the answer and E2 be the event that student guesses the answer and A be the given event that answer is correct. Now PE1 means probability that student knows the answer is 3 by 4 and PE2 is 1 by 4. Here E1, E2 are two partitions of sample space, so sum of their probabilities is equals to 1, means PE1 plus PE2 equals to 1. Now PA given E1 is equals to probability that answer is correct given that student knows the answer. So it's a sure event. That's why PA given E1 equals to 1. Now PA given E2 equals to probability that answer is correct given that student guesses the answer. So PA given E2 equals to 1 by 4. Now the probability that student knows the answer being given that answer is correct is PE1 given A. By using Bayes' theorem, we have PE1 given A equals to PE1 multiply PA given E1 divided by PE1 multiply PA given E1 plus PE2 multiply PA given E2. In next step, substitute the values of probabilities and simplify it as shown. After simplification, we get PE1 given A equals to 12 by 13. Next question. There are three coins. One is a two-headed coin having head on both faces. Another is a biased coin that comes up heads 75% of the time. And third is an unbiased coin. One of the three coins is selected at random and tossed. It shows heads. What is the probability that it was the two-headed coin? So here we need to find probability of a two-headed coin. It is given that coin shows head. As there are three types of coins, so let E1 be the event that selected coin is a two-headed, E2 be the event that selected coin is a biased coin, E3 be the event that selected coin is an unbiased coin, and A be the event that selected coin shows head. Now PE1 equals to 1 by 3 as out of three coins only one is two-headed. Similarly, PE2 is 1 by 3 and PE3 is also 1 by 3. Now PA given E1, probability that coin shows head given that coin is two-headed. It's a sure event, so probability of A given E1 equals to 1. Now PA given E2 equals to probability that coin shows head given that coin is biased. There are 75% chance that head appears on a biased coin. So PA given E2 equals to 75% equals to 75 by 100 equals to 3 by 4. Now PA given E3 equals to probability that coin shows head given that coin is unbiased means a fair coin. So PA given E3 equals to 1 by 2. Now the probability that the coin is two-headed, being given that it shows head, is PE1 given A. By using Bayes theorem, we have PE1 given A equals to PE1 multiply PA given E1 divided by PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus PE3 multiply PA given E3. Now substitute the values of probabilities as shown. Simplify it. After simplification, we get probability of E1 given A equals to 4 by 9. Next question. An insurance company insured 2000 scooter drivers, 4000 car drivers and 6000 truck drivers. The probability of an accidents are 0.01, 0.03 and 0.15 respectively. It means probability of accident of a scooter driver is 0.01, probability of accident of a car driver is 0.03 and probability of accident of a truck driver is 0.15. One of the insured person meets with an accident. What is the probability that he is a scooter driver? Let E1 be the event that insured person is a scooter driver. E2 be the event that insured person is a car driver. And E3 be the event that insured person is a truck driver. Let A be the event that insured person meets with an accident. And it is given that A has already happened. Now, total number of drivers equals to 2000 plus 4000 plus 6000 equals to 12,000. Probability of E1 equals to number of scooter drivers upon total number of drivers equals to 2000 upon 12,000 equals to 1 by 6. Similarly, PE2 equals to 4000 upon 12,000 equals to 1 by 3 and PE3 equals to 6000 upon 12,000 equals to 1 by 2. Also, PA given E1 equals to probability that insured person meets with an accident given that he is a scooter driver is 0.01 which is equals to 1 by 100. PA given E2 equals to probability that insured person meets with accident given that he is a car driver is 0.03 which is equals to 3 by 100 and PA given E3 equals to probability that insured person meets with accident given that he is a truck driver is 0.15 equals to 15 by 100 which is equals to 3 by 20. Now the probability that the driver is a scooter driver being given that he met with an accident is PE1 given A. By using Bayes theorem, we have PE1 given A equals to PE1 multiply PA given E1 divided by PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus PE3 multiply PA given E3. In next step, substitute the values of probabilities as shown. Simplify it. After simplification, we get probability of E1 given A equals to 1 by 52. Next question. In a factory which manufactures bolts, machine A, B and C manufacture respectively 25%, 35% and 40% of the bolts. Of their outputs, 5, 4 and 2% are respectively defective bolts. A bolt is drawn at random from the product and is found to be defective. what is the probability that it is manufactured by the machine B? So students, we need to find probability that bolt is manufactured by machine B. It is given that bolt drawn is defective. Let E1 be the event that bolt is manufactured by machine A, E2 be the event that bolt is manufactured by machine B, E3 be the event that bolt is manufactured by machine C, and A be the event that bolt drawn is defective. As 25% of the total bolts are manufactured by machine A, so PE1 equals to 25% equals to 25 by 100 equals to 0.25. Similarly, PE2 equals to 35% equals to 35 by 100 equals to 0.35, and PE3 equals to 40% equals to 40 by 100 equals to 0.40. As E1, E2 and E3 are the three partitions of this sample space, so PE1 plus PE2 plus PE3 must be equals to 1. Now, PA given E1 equals to probability that bolt drawn is defective given that bolt is manufactured by machine A equals to 5% equals to 5 by 100 equals to 0.05, and PA given E2 equals to probability that bolt drawn is defective given that bolt is manufactured by machine B equals to 4% equals to 4 by 100, which is equals to 0.04. Also, PA given E3 equals to probability that bolt drawn is defective given that bolt is manufactured by machine C equals to 2% equals to 2 by 100, which is equals to 0.02. Now, the probability that bolt is manufactured by machine B given that bolt is defective is PE2 given A. Using Bayes theorem, we have PE2 given A equals to PE2 multiply PA given E2 divided by PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus PE3 multiply PA given E3. In next step, substitute the values of probabilities, then simplify it as shown. After simplification, we get probability of E2 given A equals to 28 by 69. Now, home assignment. Try to solve questions of exercise 13.3. Thank you.